We're back in track doing some of our webinars. Today, I want to get through some percent stuff. Now, percents, we've talked about this before. They're important in a variety of levels on the GMAT, right? So you can see them obviously in quant, but then additionally, you know, quant comparisons, data insights is really important too, right? So you can see them in table analysis, you can see them in two-part analysis, you can see them in a lot of different cases. So we're going to look at them in quant. So the first thing I want to do is do one with a data sufficiency question. So I'm going to give you guys a minute, and then we're going to go from there. All right, so do this, put your answer in the chat box, and then we go from there. The reason you can't see the answer options is because it's data sufficiency. I never put them in when we do example data sufficiency questions. So yeah, I mean, I'm sure you guys have them memorized at this point. And yes, your reasoning why is correct. So we can talk about this a little bit. So yes, the correct answer here is in fact C. Now, it's C because you just need a percent, and the relationships here are with multiplication. So we could say A is equal to, you know, the 1856 amount. We could say B is equal to the 1857. And we could say C is equal to the 1858, right? So we want to know in a certain gold dealer's income in 1858 was what percent of 1857. So we want to know what C over B is equal to, right? Statement 1, 1857, so that's going to be B, was 20% of 1856, so that's 0.2A. 18, and of course, that's not enough information to solve, so statement 1 is out. Statement 2, 1858, which is C, is 60%, 0.6 of 1856. That's out too. Now, the thing is, you shouldn't have to spend too much time getting to a place where you know that this is sufficient. So this is where you got to save time. Like, and I have an important question for everybody here. Is there anyone who did this to the bitter end, like actually plugged in the 0.2A, the 0.6A, and got an answer? Like a real number? Anyone? All right, well, I'm going to assume nobody did. Yeah, but do you see that you didn't, do you see, okay, you wouldn't do it on the test. Exactly, okay, so that's good. Yeah, so I want to make sure that nobody actually would do that because you don't want to waste that time. So the moment that we were in a position where you knew you could solve it, you just say, hey, it works, and you go from there. So hopefully you guys are all in that same boat and nobody did more work than they needed to. So again, the answer here is C. Now, the other thing I want to mention, and you guys have heard me say this before, if this was asking about a ratio, or this was asking about, say, a percent increase, right? Do you guys think it also would be sufficient? Or let's say it's asking about a fraction of. Do you guys also think that would have been sufficient in addition? All right, well, yeah, exactly. So what I want you guys to understand is all of these things are kind of sisters and brothers of these. Yes, the answer options aren't there because you have them memorized because it's data efficiency. If you don't have them memorized, get them memorized. So yeah, so what I want you guys to understand is these are all like siblings of each other, ratios, percent increase, fractions, percent of. So if you can get one of them, you can get all of them. So keep that in mind. That's going to help you a lot. And the more links you can make between concepts, the better off you'll be on this test because then you're going to have to learn one thing and it can be dispersed among 5 different concepts or topics. So keep that in the back of your mind. All right. Next, let's do this here. so this one's interesting. It has a trap in it. Looks like no one fell for the trap. Anyone thought it was D at any point? Looks like no, but I'll show you what the trap is. So first of all, when we're saying we want to know y expressed in terms of x is what percent of z. So we really just want to get y over z. The key here is times 100, right? Now, we're just going to take this initial equation and manipulate it to get y over z and then multiply it. So x percent of y, so that's x over 100 times y is equal to z. All we really need to do here is divide this over here and to bring the z over here, giving us y over z is equal to 100 over x. Now, that's obviously where this trap answer comes in, because the one thing is you have to multiply both sides by 100, and then once you do that, you get 10,000 over x. So the answer here is obviously E. So again, good job not falling for that trap. Looks like most of you didn't. I want to talk about some variable percents too. So this is a good question here. And also like increase and decrease of percent. So take a look at this here. Give you guys a couple minutes and we'll chat about it. All right, so there's a bunch of different ways to deal with this question. Did you guys plug in real numbers? Oh, it's funny, someone just said that for me even asking. I will show you a cool approach. Did most of you plug in numbers here? This is one time I actually don't. Okay. I want to show you guys something kind of interesting. So and it is kind of almost a well, not logical way, but there's something kind of cool that you can do where you don't actually have to do it all the way out. So, and to be quite honest, this is something you could kind of take to the bank and use for pretty much any one of these types of. So check this out. We have wage times hours, and that's going to be equal to a 25% pay increase, which is 1.25 times a wage times some sort of decrease in hours, 100 minus X. Oops, 100 over 100 times the hours. So do you guys agree with that so far? Everyone's on the same page with that? I'm going to assume the answer is yes. Now, does everyone agree that the WHs cancel? And if you guys, when I ask these things, you can just type it in the chat box if you can. Those cancel out, right? Now, we have a 1 on the left. We have a 5 over 4 on the right times 100 minus X over 100. Everyone's still good? Now, you move that, you keep it there. All you have to ask yourself is, what do I need to multiply 5 over 4 by so that when I do, the answer is 1 on the left-hand side? What's that number going to be? Exactly, 4 over 5. So this here is equal to 4 over 5. And all you have to do to finish it is subtract 4 over 5 from 1, which is going to give you 0.2 or 20%. The flip side is you could have actually solved for X, but there's no point because you can get this much quicker just doing this and saying, well, what does 100 minus X over 100 have to represent? So my question to everybody is, does that make sense? Because it's percent less. So it's a fraction, it would be from 1. If it was a percent, you'd subtract it from 100. I mean, I guess you could say, 4 over 5 is equivalent to 80%, and then you're doing 100 minus 80, which is 20%. Doesn't matter, but you have to subtract from 1 because it's percent less. No, you can substitute numbers. That's a fine approach too. I just think that this is a very clean, simple way to get there. And this works irrespective of the type of problem you're dealing with. So like, let me try to find another similar one so you guys can see what I'm talking about. Like, okay, hold on. And again, you guys can do it out any way you want. I mean, this is very similar. This is just a decrease compared to an increase, but like, if you can understand that the decreases and increases are just inverses of each other, you'll be set. It'll be super simple. So like, do this question out. I'll give you guys a minute or two, but you're going to find that it's pretty stinking easy if you follow the method I just showed you. So give this a shot, and I'm just going to do it super quick using my method after, and then I want to show you how that relates to the previous. All right, so here's the crazy thing. The item is decreased by 20%. You guys agree that that's 4 over 5, right? The decrease of 20%? Yeah. So to bring it back to where it needs to go, you guys agree we just multiply by 5 over 4, correct? Five over 4 is 1.25. We want to make it a decimal. Minus 1, because instead this is a greater, not a less. So instead of being subtracted from 1, we are subtracting 1. You get 0.25, which is 25%. Now, I don't see there being a faster way to do this than that. You can set it up, you can solve for terms, you can plug in values, but do you see how quick and simple this is? And we did the same thing here. Instead, we're reducing from 5 over 4, so multiplying by 4 over 5. So anyway, I hope you guys can see the simplicity in what we're doing and how it can relate to a lot of different problems that we could see like this. Does anyone have any questions about this or your ability to use it? I mean, we have a ton of these types of questions in our percents chapter, so you could certainly use them there. It's not a big deal, but just want to make sure you guys feel good about this. All right, here's there's no questions now. We're going to move to something different with variable percents here. And take a look at this here. Is it a successive increase concept? I don't think so. No, it's just when you're taking something that's been decreased and trying to bring it back to its original point. Well, you don't have to use this method. So I'm not saying anyone here has to use it. It's just a way to show how you have to bring a percent back to where it came from. Well, the 1 came from, we have to subtract 1 to figure out what percent we actually needed. And here, we subtracted the 4/5 from 1. Again, this isn't something you have to use, but it's something you could just play around with. I guess the thing you need to understand, the trap on the GMAT is if someone says something decreased by 20%, by what percent do I need to increase it to get it back to its original? Most people who don't understand percents are going to say, oh, well, that's easy. You decrease by 20%. I have to then increase by 20%. That's not true. And you could test it out. You could do it all day long with a calculator. It's not going to work out. Yes, what was just said, so it's reciprocal logic with the increase. Yes. So if something is decreased by 20%, you put it in a fraction form and you say, well, what do I have to increase it to get it back to where I started? It's just the reciprocal. So if something is decreased by, 30%, then that's 0.3 or 3 over 10, right? 7 over 10. If you decrease by 30%, it's like multiplying by 7 over 10. So how do I get that back to the level that it started at? You would multiply by 10 over 7. It's that simple. But again, if this is something that isn't sticking at the moment, it's okay. But I want everyone here to understand that's the underlying logic of all of these questions. Whether it's this, which is pretty straightforward, or this, which introduces extra variables, but those variables ended up canceling out anyway. So mess around with this. Go into our course. When you see questions like this, mess around with it. I'm telling you, or mess around with it in general. Just do, hey, percent decrease, percent increase, percent increase, percent decrease. Eventually, you're going to say, oh, yeah, it's always the reciprocal. All right, let's do one more question here, then we can do some Q&A. All right, so I see some answers coming in here. It shouldn't have been too bad. This is not the same type of question. So we have the $500 computer increasing by n%. So that's going to be 100 plus n over 100. And the laptop decreasing, they're going to be equal. So 100 minus n over 100. Now, there's a $60 printer. We'll do that at the end. So first of all, you can get rid of the 500. It goes into that 400 times, or excuse me, 4 times. So then you have 100 plus n over 100 is equal to 400 minus 4n over 100. Now, be smart when you're cross-multiplying. And again, if you know what's about to happen, you can do this in your head, but notice the 100 doesn't have to be distributed because it's just going to cancel out, right? So just get rid of it. And then this becomes much easier. You bring the 4n over, 5n is equal to 300, or n is equal to 60. So if it's marked down n%, you just do 60 times 0.4, which is 240. Or excuse me, which is 24, not 240. B. All right. We did a lot of stuff. Hopefully you guys, learned a thing or two. And yeah, I think today went really, really well. So any questions about anything? Target Test Prep, your study plan, anything? Your GMAT, your studying? You get better at hard questions by just doing a lot of practice and being providing yourself with some being hyper aware of why you're getting questions wrong. What part of the question? Is it the concept? Is it the math? Is it the mix of concepts? I mean, it's like anything in life. You just have to keep at it and continue practicing, but also understand that you don't have to get every single hard question right on the GMAT to do well. When students don't do well, it's not about the hard questions. It's about the ones you should be getting right that are in your wheelhouse and maybe you're getting wrong. So consider that as you're going through, your studying. Any other questions? Oh, I see there's more. We did one recently on probability and combinations, and you can check out our YouTube. I think they're up there. There are no biggest topic areas. This is the biggest question asked by students across the world. What's tested the most? GMAT isn't going to tell us what's tested the most. They never have, they never will. There's 23 questions in quant. That's not a lot. It can come from anywhere. From test to test, it can be completely different. So you just got to be ready for that and for a random distribution. I wish I had an answer, but if it existed, we'd all be doing that much better on the test. These questions were a mix of medium, I'd say medium-ish. You can use AI while studying, yes, but just, take certain things with a grain of salt. AI isn't perfect. So, you can't take what they're saying as gold. Sometimes you got to see if there's an issue. But yeah, AI is certainly helpful and can be helpful for sure. And remember, we have AI in TTP. There's a chatbot there that's great that we've been training. So yeah, I would say to use that before doing anything else. I doubt we will do a data insight session. Usually I just do quant. All right, any other questions? You get instant answers from TTP. Well, that's great. Yeah, that's why we have our AI. I'm glad you get that. Other resources, I mean, the official guide is the only other resource, like official stuff that I would mention. AI generated questions from the quant sesh. I think you might mean from TTP. Yes, I would say you can definitely create new questions that we allow on TTP using our AI for sure. Any other questions? All right, cool. So if no one has any, oh, there's another question. The sessions focus on verbal. Those happen about once a week, just like quant. Towards the end of the month, we usually don't do them. So, but yeah, there's usually one quant, one verbal in any given week. All right, cool. Well, listen, everybody, good work today. Keep it up, study hard. Reach out to us on TTP if you need us. I will be back next week. Not sure what I'm going to do, but I'll be back nonetheless to do another session. So thanks for coming, everybody. Thanks for participating, and have a good, safe, healthy weekend. Talk to everybody soon.